Hi, this is Jim Bergman with Stride Tool. Wanted to tell you about a new product we're coming out with that is going to include a new app, and the app we're going to make for free because we found so much use for the application on its own that we thought we'd give the app away for free so everybody could get a little bit of use out of this thing. Today I want to take a few minutes and go over with you exactly what the app does and how it works. And again, this is a free application, so it is a little bit limited in what it does compared to the full app, but the full app is going to work with a new product, and you're going to have to wait and come to the show to see it. Alright guys, so just so we're clear, we're going to keep the iManifold quiet for now. We don't want people to know that we have a totally new product on a totally new platform with wireless Zigbee probes, with wired probes that are compatible with Cooper-Atkins products. We don't want them to know yet that it works with both Android and iPhone, and you can have it on your display and be 1,000 feet away from the iManifold, maybe downstairs adjusting a thermostat, and still have communication with your smart device. What we need to focus on today is our application and teach guys a little bit about what we can do with the free app that we're going to give away so that people get a little bit excited about that, and then we'll really wow them when we get to the show. Caught your interest yet? What you're looking at is the world's first commercially available iManifold. It's recording at 4 times per second. Just introduce some hot gas into the system, into the suction line, so you can see the gauge needles move. Gives it an analog feel and the digital accuracy and display. So get ready to see something a little bit different than you might have ever seen before. So the first thing you're going to notice when you look at our application is that we went with a very traditional look to the application. Standard gauges, indicator on there showing you where the pressure's at, but yet the accuracy of the digital instrument. The next thing to notice here is what we call the saturation bar. Saturation temperature is the point at which refrigerant exists as both a liquid and a gas simultaneously. If we're above saturation, we're superheated, and this indicator carries that across as superheated. If we're below saturation, like over here, we're subcooled. So this is our subcooling, and this is superheat on the indicators. These are arbitrary scales. So right now the scale is at 0 to 30 degrees to superheat and 0 to 30 degrees to subcooling. The center of the scale would be 15 degrees respectively. When you first start using the app, the first thing to notice is there's 2 menus here. There's over here is our applications menu, and the gear over here is our settings menu. Those menus can be opened by touching the menu button itself or by simply swiping it to open it left or right. Very simple to use. One of the first things I recommend, just so you get an idea what the app does, is open up the user inputs, and we've put in some default readings, and those default readings you can scroll through all of those and look at them. But first things first, don't adjust them. Just let them sit the way that they are so you can get a little bit familiar with how the gauge operates. These readings were off of a typical 410A system, so it's going to give you a very good idea of how things will look. So we're going to hit submit here, and when we hit submit, you can see the pressures automatically go to the top and they peg out. Now the reason is that they do that is because by default here I have this set to refrigerant 134A. I need to go in and change that refrigerant, so for now I'm going to go over to my settings button, manage refrigerants. When I do that, it's going to pull up a list of all the refrigerants that are in the gauge. I'm going to hit make active, and when I make that refrigerant active, now you can see it goes back into what looks like more normal readings. Now if you notice, if you looked at the beginning there, that the gauge on 134A went from 0 to 80, now it's 0 to 250, and it was 0 to 300, now it's 0 to 600, because when we change from a low to a medium to a high pressure refrigerant, the gauge automatically rescales to a scale that would be typical for the refrigerant that you're working on. One of the most frustrating things for guys when they buy a digital instrument is managing all those refrigerants. I mean, I showed you earlier here that we have over 40 refrigerants loaded into our gauge set, and this makes it really easy to navigate with a scroll up and down. You don't have to toggle through all of them, but it's still not as easy as we wanted to make it. So I'm going to go back to the manifold here and show you how we address that situation. So when you touch the center refrigerant, you can say there's a refrigerant quick select, and we can add refrigerants there. So what I'm going to do is I'm going to add refrigerants, and the order that I select the refrigerant in will be the order of the display in the quick select. So if typically I work on mostly 410A systems, I add that to the quick select, and I say, well, next most typical for me is R22, then 134A, and then 404A. Now when I go back to the manifold and I hit my refrigerant again, you can see those are all in my quick select. Now if I want to switch, all I do is bump R22, it's changed. When I go back, 404A, touch it, there it goes back to 404A. When I go back to 410A, boom, I'm back there again. If I want to go in and I want to add a refrigerant, I just edit my list, hit edit, and let's say that I want to add in R407A. I add that to the quick select, go back to manifold. Now when I hit it, I'm there again. Now another cool feature of this is, let's say that, R290, not a typical refrigerant I work with. So I want to work with R290 today. All I have to do is go back to Manage Refrigerants, find R290 in the list. Oops, so we'll shut that up. Hit the quick select, find R290 in the list, hit Make Active, and R290 is displayed. So this allows me to either add them to my quick profile to make them really easy to manage and use, or as you can see when I go back and hit R290, it's not in the list here because I didn't add it to the quick list. It makes it very easy to switch back and use the refrigerants that I want to use on a daily basis. So when developing the iManifold app, we knew that this instrument would be used across the world, and we wanted to make it very simple to set up and use the instrument. So in the settings menu, if you need to change units of measure, because country specific, we want to change this to bar and degrees Celsius, and maybe we want to use let's say hectopascals for vacuum unit. We hit those units, we go back to iManifold, and the units are automatically updated and changed. It's just that easy. You can see here, these are for T1 to T4 are all now degrees centigrade, and if we want to change those units back, we just simply go back to, again, units of measure. We go back to PSIG, degrees Fahrenheit, inches of mercury, hit the manifold button, and they're changed back again. Super simple and intuitive. One of the things we did when we were developing the iManifold and the iManifold app was we realized right away there's going to be a lot of measurements required. So our gauge manifold doesn't do just 2 measurements, it actually does 4. Now the cool thing is these measurements can be mapped to whatever we want to map them to. In other words, the same probe can be used for multiple measurements. They're not dedicated to one fixed spot. So in this case here, you can see we got T1 through T4. We can tap on the T1 key and you'll see it comes up with a list of points to map it. And what we're doing is telling the gauge what we're using that probe for. So in this case, I'm going to pick them in order. I want it to be the suction line temperature. T2, and you can see right away so when it went to suction line, now it started showing the superheat on the gauge because it's now mapped to a point. T2, I'm going to make liquid line temperature. T3, discharge line, and T4, outdoor air. Now I have all these probes mapped and I'm telling the gauge what I'm doing with them. So now the gauge will make all the calculations of superheat, subcooling, and display the discharge line temperature on the display. Alright, so now that we have the probes mapped, one thing I want to show you is on the bottom of your display, you can swipe this left or right, or you can use the arrows, and you'll see that it navigates through more probes that are on the display. When the wireless probes are available here in a couple weeks, you're going to be able to use supply air, dry bulb, and wet bulb, return air, dry bulb, and wet bulb. You can see those temperature displayed. Right now we're putting them in as user inputs. You swipe again, you get the suction line, liquid line, discharge line, and outdoor air. You swipe again, and it's going to give you some performance data of tons, BTUs per hour, kilowatts, and EER. Those are done off of the system performance, which I'll show you on a deeper menu of that a little later. Alright, so now let's go over what I think is probably one of our coolest features in the whole application, which is equipment profiling. And profiling is something you've been doing your entire career. It's really just telling me what the equipment is. So in the app here, when we hit equipment profiling, you'll see the drop-down menu, right? And if we're going out and working on a job, we need to know, well, do we have a 13 SEER 410A TXV system, or do we have a 10 SEER R22 fixed system? These are just simply what type of system are you hooking the gauges up to. When you tell the gauges that, when we select this 13 SEER 410A TXV system, What it does is it puts an indicator up on the gauge set that shows you where the pressure should be. It puts it on the high side that shows you what the pressure should be, and it calculates our targets for our superheat and our subcooling. Now when we talk about targets, if we scroll back a couple menus here till we see the target indicator, now you can see our target suction pressure is 118, our target superheat is 10, our target subcooling is 17, and our target high pressure is 342. Well, you can see, looking at the gauge, our pressure is actually 350, so this is above the target, and that's where the gauge is. We're 118 here for target suction pressure, which is exactly matching, so that's fine. Our target superheat is 10, and we're at 20.8, so it's off the scale, way above the target. And then our target subcooling here is 17, we're at 21, and we're obviously below target there. Now, when we talk about target, this is a real important thing to understand here. This is plus or minus 3 degrees of saturation temperature, plus or minus 3 degrees of saturation, subcooling plus or minus 3, and then superheat is plus or minus 5. Those are the allowable deviation from the saturation temperatures or superheat or subcooling. That comes from ACA quality installation guidelines. How far off can we be before that pressure starts to matter? And this will lead us into a lot of the more complex features that the gauge will do by understanding what the profiling does. Now, a couple other things here. We can also profile a new system. And when we profile a new system, what this allows us to do is tell it what type of system we have. So right now it defaulted to the current system profile, which is 410A, air conditioning with a standard TXV, with a 13 to 16 SEER condenser. And you'll notice here that if you look at these, it says what the design temperature differences are. So an old 6 to 8 SEER condenser was 30 degrees hotter. Mid efficiency was plus 25, and now high efficiency is plus 20, right? Those are design temperature difference. Standard evaporator, our target superheat and subcooling, and then a profile name. So this is the default profile. If we were to come in here and change our target superheat or target subcooling, let's say we want to change this to 9 degrees. So we turn that to 9 degrees, and then we'll just submit that. What you'll notice down here is that scale changed from 34 to 18. We're obviously at 21 degrees, so that dropped down even further. Let's go back, we'll change it to 20 degrees, and I'll show it to go to the center of the scale. So now we'll go back in, we'll go to our profile new system. We'll change this to 20 degrees. Hit submit. And you can see now it goes down to almost to the center of the scale. Now our target's 20, we're at 21, it's plus or minus 3, so we're not exactly on target. If we put the target at 21.3, it would be exactly in the center of the target. So you can see I can adjust these profiles to meet your equipment needs. So when I said that profiling is the secret to allowing us to reach the maximum potential of the gauge set, here's what I mean by that. So let's just take a look at what we have here. So we can see again our target suction pressure is 118, we're matched. Our target superheat here is 10, we're at 10.8, that's perfect. Our target subcooling is 20, we're at 21.3, we're fine. Our target high pressure is 342, we're at 350, but we're still within range. We're still within range on the subcooling, so everything looks okay. If I were to go over here and slide over, we have what's called the troubleshooting feature. I can turn that troubleshooting feature on by just touching the button. When I turn it on, well, nothing exciting really happens, and that's because there's nothing wrong with this system. Well, let's look what happens when I change my user inputs, and let's say that actually my head pressure, instead of being 350, was actually at 380. So I'll put 380, and I'm going to hit submit here. Now when I drive that 380 up, what's going to happen? My pressure increases, and it changes my saturation temp up to 112, which also increased my subcooling because my liquid temperature pretty much stayed the same, right? Well, this is classic symptoms of what? Well, let's take a look. High subcooling, high head pressure. Remember, it's a TXV system, so the superheat should remain pretty much constant because the TXV is going to maintain constant superheat. Evaporator, nothing changed, so the suction pressure is going to stay the same. Touch the troubleshoot button. It's running symptoms of a refrigerant overcharge. classic overcharge right here. Well, what are those symptoms? We touch that button and it tells us step by step here, the diagnosis indicates it's overcharge. There's too much refrigerant in the system. It's got normal suction pressure, high liquid pressure, normal evaporator superheat, high subcooling, normal relative humidity control, and an overcharge will result in reduced cooling capacity and increased operational costs due to increased head pressure. What are the recommendations? Adjust charge to the manufacturer's recommended levels, recover excess refrigerant using an improved method. So it'll actually troubleshoot the system for you, help you out with what's wrong. This is really cool because this allows you to show your customer that yes, there's a problem. Here it's indicated on my gauge. Here's what the recommendation is. Here's what the operational characteristics are, and it lends to your credibility as a contractor that you actually understand and know what you're doing. You can turn this feature on or off. So if you don't want to use this feature, you simply slide it over to the right, turn troubleshooting off. The indicator will go away. And so if you know what you're doing, you don't want the device to do the troubleshooting for you, you don't have to use that feature. But it's an extremely powerful feature to help you out, especially when you get a little lost, you're looking at something you're not quite sure what's going on. Very powerful feature to help troubleshoot the system. Now, one other cool thing with this feature is if we turn this back on again, is not only does it tell you put check marks, and so right here it says the head pressure is high, superheat's normal, subcooling is high, but you can also touch the individual problems and it'll tell you what causes high liquid/discharge pressure, right? We can touch the subcooling, what causes high subcooling. So if there's a problem that's indicated on here, in this case the refrigerant overcharge, by these 4 conditions, it'll indicate what that problem is. If it was just a problem of high suction pressure or high head pressure or low head pressure or an individual problem, you can also diagnose each one of those symptoms individually. So very, very powerful feature, makes the gauge set extremely useful for technicians to troubleshoot faster. So one of the last things I want to show you the gauge set does, really cool, never been done on a digital gauge set before, is system performance. When we click on a system performance, what it does is if the user inputs airflow in the user measurements and 2 wireless probes, a supplier wet bulb and dry bulb, returner wet bulb and dry bulb, or you just put those measurements in by hand, it'll calculate for you the performance of the system. So what we have here is our capacity. We put in a 1200 CFM of airflow. That generated 3.66 tons of cooling, 43,869 BTUs. Our sensible BTUs, our latent BTUs, our kilowatts, our kilowatt sensible and latent, our sensible heat ratio of 0.74, or bypass factor in a coil. We can look at, if we put in electrical readings, we can get all of our watts, and then it'll calculate our condenser EER, and then it'll do our dehumidification in pounds per hour or gallons per hour. Now, just to walk you back where those came from, that goes back to the user inputs. Now, the user inputs, in this case, were all put in by hand. So I put in pressures, temperatures, air side measurements, which are supplier, dry bulb and wet bulb, return air, dry bulb and wet bulb, our CFM, some electrical measurements here for the condenser, and electrical measurements here for the air handler. Each one of those were put in. If you're using it with a gauge set, a lot of these measurements are automatically populated and dynamically updated. So as the machine's running, you're seeing these changes in real time. And if you go back to the manifold, what you can do here is you can actually look at tons, BTUs, kilowatts, and EER in real time. So if you had a machine, let's say, that was undercharged or overcharged, as you added or removed gas, you'd actually see the performance change on the system. You can see that EER increasing as you get the system operating correctly, and you'll also see an increase typically in your BTU output. So again, this is completely new technology, something you probably haven't seen before, and it should really change the way that you do your work. And last but not least, there is a help section of the application and about this app. And the help section goes over what all our abbreviations are and a little bit about profiling what the app does. And then there's about this app, which is simply our disclaimer. The app is in beta version, as you'll see. So If you do find any problems, there's a website address on here. If you could report them back to us, it would be greatly appreciated. We'd really like to know how the app's working for you and get some positive feedback from you guys, or negative feedback, whatever it might be. Just so everybody understands, now the app is only supported in Apple iOS and Android Jelly Bean 4.0 or higher, so it will not work necessarily correctly in some of the Windows phones that are out there. We haven't written the application for those types of devices. But if you do have any other feedback or any other comments on it, we'd love to hear them, and would really appreciate getting that information back from you. All right, so this is Jim Bergman for Imperial Tool. If you get a minute, stop by the AHR booth. We are booth 930 at the expo. I think we're on level 3. And if you say you watch this video, we'll let you take a look at our app through our newly acquired Google Glass. It allows you to have the app on a true heads-up display. So if you get a minute, you can stop by the booth to say hi, take a look at the app on the heads-up display. That'd be awesome. This is Jim for Imperial Tool. Thanks a lot for watching. So some other cool features you're going to see at the product release. One is reporting. We got a full reporting app that also allows you to geotag the location. So it'll pull up a map. Right now it's pulling up our Stride Tool company here. We can enlarge the map. We can take and drop that pin on the unit that we're working on. It records the longitude and latitude and also picks up the address. So when we hit back here and we hit customer data, obviously we can do voice input, Jim, Bergman, Stride Tool. And then when we go down here and hit the submit key, it populates all those addresses and things in there. We can pull in our current weather data. It'll go out and pull in. You can see we're light snow here today in Ohio. And our temperature, it'll record our live measurement data, our system performance. We can do a test in, and we can do a test out. And then we can also generate a report, and it'll send that data out to email, and an email report back to you. Another great feature on the instrument is going to be equipment trending. So we can go in here and trend the system. When we start trending, it'll plot out a graph of the actual equipment operation. And this, my friends, is why it's called beta.